Welcome back to another video. So this video is part of DSA revision series. So in previous video we have solved one problem called insert interval. So that was pretty straightforward problem where we simply read the brute force and it worked. So in today's video we are going to do three sum problem. So in this problem the basic requirement is to find a triplet where the sum of individual elements is equals to 0. So this problem is nothing but an extension of two sum problem. So before approaching for this problem, let's do two sum first. Okay, so this is the two sum problem, and in this problem we have given an array nums and target return indices of two numbers such that they add up to the target. Okay, for example, if this is the input and target is 9, then 2 plus 7 is 9, obviously. And another example 6, then 4 and 2, it means 1 or 2 will become 9. So brute force solution is simple. Generate all the pairs and check if the sum of the element is 9. But uh, but a smart solution to this problem is utilizing the previously visited elements. For example, if I am seeing 2, it means um, I can check for 7 in future, and if I see 7, it means that makes my pair, something like that. Okay, so and for this example we have seen 3, then we can keep 6 minus 3 in our sum data structure with the index, and if it matches then we'll have our answer. So you can return answer in any order, and you may not use the same element twice. Okay, only one valid answer exists, so this is the constraint. So let's quickly code the solution. So I will be using hash set with integer for keeping the basically remaining part of the target, and another for basically index. So map new hash map. Okay, why I have named it hash map hash set? It should be hash map only. Now I start a loop for int I equals to 0 to I less than nums dot length I plus plus. I'll see if my map dot contains key. uh, key should be nums of I is there, then answer should be int answer equals to new int of 2 uh, answer dot 0 equals to uh, any order. So I'll keep map dot get nums of I. Okay, and answer of 1 will be this I. Okay, and map dot put minus of nums, sorry, target minus nums of I for future reference. Return answer. So this is it. Yeah, this worked. So basically we have utilized this hash map thing to keep the track of indexes, and yeah, so this worked. Now go back to the previous problem, which is theism. 1 second, my phone. Okay, so now we have seen two sum. Let's jump into the three sum as well. So three sum can become two sum if we fix one element via one iteration and find two pairs that will constitute minus k, something like that. So if you see our two sum problem which we just solved, then we can utilize same logic here as well. So I'll quickly initialize list of integer to store answer. I am taking set because we do not want duplicate triplets. So let's initialize it as set. Okay, now we can start the loop. Okay, before starting loop, let me quickly take a variable for length as well, which is nums dot length. Okay, now int I equals to 0, I is less than n, I plus plus. So this is outer variable, and here we will get nums of I. Okay, now we can start another loop which will be j, which is equals to I plus 1, j is less than n, semicolon, j plus plus. Okay, now we have I and j both in place. Then we can just find k, which is equals to negative of nums I plus nums j. Okay, now we can introduce the same logic as of two sum. Check if we have found this negative previously or not. To check that, we can simply have a set of integers. We don't need hash map because we can simply return the elements, not the indices. So hash map is not required. Hash set is sufficient here. Hash set. Okay. We can simply check if our set contains k, then we found triplet, and triplet will consist of these three elements: arrays dot as list, which is k, nums of I, and nums of j. Nums I, nums j. Okay, and we need to short this temp as well. Then we can short by passing a custom comparator e minus f. This is sorted, and we can add it to answer dot add temp. Okay, we are good till now. And after doing this thing, we can add the current element to the set so that we can utilize it in next iterations. Also, this part is for two sum because I we have fixed as first integer, so we need to clear the set as well before each iteration. So we have cleared the set, and after this we can return new array list of answers. Okay, let's quickly check if this compiles fine. Set dot contains. Okay, contains. Nums I, nums j, k. This is correct. What are we doing wrong? Set we have initialized I, j, n, nums I, nums j is k. Answer we have added 422. It has taken some element again, which it shouldn't. Oh, I am adding nums I. I should add nums j. Yeah, So let's try to submit it. Yeah, so this was it. So we have solved the sum problem in this video, and I'll see you in the next one.